In this video, we will learn how to integrate Vortex Studio simulations in the Unity game engine. Vortex Studio is a high-quality, real-time, multi-body simulation software with which we can create complex machines in dynamic environments. With its flexible cable systems, deformable soil and terrain mechanics, as well as fluid extensions, you can accurately simulate robots, heavy machinery such as lifting and earth-moving equipment, offshore and subsea system, as well as any type of wheel or tracked vehicle systems. With the release of Vortex Studio 2021A, all of this power is now unlocked with high-quality 3D graphics in the Unity game engine. In order to complete this tutorial, you need to have Unity 2020.3 or newer installed, Vortex Studio 2021A or newer installed, as well as the optional Vortex Studio samples package installed. The first thing we're going to do is create a new project in Unity. So let's name the project Vortex Simulation, and you can choose a proper location for your project. Also make sure that you select High Definition RP as the template. Now that our project is created, we'll install the Vortex plugin to our project. To do that, browse to the installation folder of Vortex Studio and look for bin Unity, and you will find the Vortex integration package file in that folder. Copy that file, and in your Unity project, browse to the package folder and paste the plugin there. Next thing we'll want to do is to edit the manifest.json file in order to include the Vortex integration plugin dependency. What we can do is we can simply copy and paste the first line and modify this first part here to be com.cmlabs in one word .vortex .integration. And instead of specifying a version number here, we're going to specify file and the file name. So we can simply copy that file name here and paste it in that section. So let's save this. And we can already go back to our Unity project and see that Unity is already importing this package. To make sure that the plugin was properly installed, we can go to Window, Package Manager, and we'll see that we have here our Vortex Studio Unity integration. With this plugin installed, we now have access to settings that are specific to Vortex Studio. For instance, if we go into the Edit tab, we see that we now have a Vortex Settings option. In there, we'll find an option for the Vortex Setup document. By default, this will use a default setup file that is found in the Vortex Studio install folder. As you may know, the setup file will define exactly which extensions and libraries the Vortex application will load upon launch. Next, we have the material table. So this file defines the physical properties of the materials in the Vortex simulation. We also have an optional log file path. So this will define exactly where the logs of the Vortex simulation will be saved. For now, we'll use the default values for these options, but if you want to use your own files for these options, make sure that these are saved under the Streaming Assets folder of your project. The plugin also added this Vortex tab here, which gives us the shortcuts to either launch the Vortex editor, launch the remote debugger, or edit the setup document. We'll actually use it now to edit our setup document. So let's click on this. And this should open the currently used setup file in Vortex Studio. So if we go into the Explorer, we can click on the root of the setup and we'll find useful options like the simulation frame rate. So by default, it's at 60 Hertz, but that can be modified. Here we'll keep it at 60. And we can also activate the remote access with a listening port. So let's put this at 55,000. This will let us debug our simulation later using the remote debugger. If you expand that setup file, you will also see everything that is being loaded by Vortex. And you can, of course, modify or add extensions or modules in that setup file. So let's save this and close Vortex. Now, the next thing that we need to do is we need to make sure that the frame rate that Unity is using is the same as our Vortex simulation. So for this, we can go into Edit, Project Settings, and in the Time section, we'll have a fixed time step option. So since we're working at 60 Hertz, let's put this at 0.016 seconds. And the maximum allowed time step, we can put this at 2 times the value, so 0.033. Okay, let's close this. So now we're ready to import our first Vortex Studio mechanism into our Unity project. To do that, we'll use the samples package that can be installed with Vortex Studio. If you don't have it installed, go back to cm-labs/downloads and download that package. It can be found under C, CM Labs, Vortex Studio content. So we'll copy this whole folder into the streaming assets folder of our Unity project. So this will be under assets, streaming assets, and then we can copy that whole folder. The mechanism we're going to be importing is the pickup truck from the vehicles of the samples. So if we go look at the samples folder we just copied in vehicles, we're going to find pickup truck here. Now we can directly open that mechanism in Vortex. If your file is not associated with Vortex, you can always right click on it and then click on open with and choose the Vortex Studio executable. Now from here, what we need to do is we need to export the graphics gallery of this model into an Fbx file that Unity can recognize. So from the Explorer, we can expand our mechanism, and we'll see that there's a graphics folder with the pickup truck graphic gallery. So we can right click on that and go to Gallery Tools and then click on Export. Now browse to the Unity project, go to Assets, and from there we can create a folder. This is going to be temporary anyway, so we can name it pickup truck FBX. And we also need to name the Fbx file, so let's name it pickup truck. Now if we go back to Unity, we'll see that it will recognize our new folder, and we'll also see that our Fbx file was imported. If we go to the properties of the Fbx file in the model section, we need to make sure that the preserve hierarchy option is activated. And let's apply. This will make sure that the node hierarchy from the graphics gallery is preserved, and that way we'll make sure that the parts are animated properly. Also in the materials section, we'll set the material creation mode to import via material description, and we'll also use embed the materials as a location. Now we can click on extract materials, and it will automatically recognize the materials, and it will create the corresponding materials in our folder. So the next thing we're going to do is create a prefab from this Fbx file. To do that, let's insert a truck in the scene, and then from the hierarchy view, simply drag and drop that object back into the Explorer, and then click on Original Prefab. Now you'll notice that there's some unwanted volumes on the truck. These are shadow volumes used by Vortex. So we'll just want to delete those. In order to do that, just double click on the prefab we just created. And in the hierarchy of that prefab, we can search for all of the objects with SV in their name. We can simply search for SV, select them all, and delete them. Save this, and our truck is now clean. So this model is now ready to be associated with its Vortex mechanism counterpart. So what we can do here is right click on the pickup truck Fbx folder that we created, and we'll choose Vortex and then export asset bundle. Then confirm. We'll want to save this asset bundle at the same location as the graphics gallery of the pickup truck. So let's go into streaming assets, samples, vehicles, pickup truck, and then the graphics folder. So if we go back to our pickup truck folder in the Windows Explorer, and we go to its graphics folder, we'll see that we now have a Unity 3D file called pickup truck FBX. Now, in order for the Vortex plugin to associate that graphics gallery and that asset bundle, the name of the asset bundle needs to be exactly the same as the graphics gallery. So here we need to remove the FBX word from that file. You can also delete the meta file, and Unity will just create a new one. So to test this, let's create an empty scene. So File, New Scene, then Empty. We don't need to save the scene we were working on. So here, let's create a test terrain for a vehicle. So let's just create a 3D object, terrain. So the terrain will be recognized by the Vortex plugin, and the mesh of the terrain will be streamed to the Vortex simulation. So our truck should automatically collide with that terrain and be able to drive on it. Next, we'll create an empty game object that we will call pickup truck. And to that object, we'll add a component. You can search for the Vortex keyword. So what we want to add to that object is our pickup truck mechanism. So let's choose Vortex mechanism. Now we can simply assign the mechanism found in streaming assets, samples, vehicles, and then our pickup truck. And the mechanism file can just simply be drag and dropped into that field. So we can already test this. Maybe let's make sure that our pickup truck will be spawned on the terrain. So let's say 0, 0, 0, and then we can maybe move it around on the ground so it will not fall infinitely. So here, if we press play, we should expect the Vortex plugin to spawn the Vortex application. And since we have an object that loads in the pickup truck mechanism, we should expect the pickup truck to be loaded with its graphics associated. Here we don't have a camera, so we might have to go to the scene tab in order to have a better visualization. And we can see here that our pickup truck is loaded. Now, if you have the default setup file loaded in your project, you should also have this Vortex player window, okay? And you have a play button here in order to start the Vortex simulation. From that same window, we'll also be able to access the content debugger, right? We can enable that debugger, and this will allow us to look at the content that's in our simulation, and we can access the vehicle interface of our pickup truck. Now, in that interface, we have an option to activate the engine. We can select the gear of the vehicle. Oops. And we can also, for instance, throttle and steer. Now that we have our truck simulation working, we're going to use a C# script in order to access some of the inputs and outputs that are exposed in the truck mechanism. So before we create a C# script, let's go back to Vortex and look at our truck mechanism. If you've already closed Vortex, you can always right-click on the truck mechanism and click on Open in Vortex Editor. One important thing to remember is that when using the Unity plugin, the data can only be accessed through a VHL, which stands for Vortex High-Level Interface. So if we look at our pickup truck here, we can see that there's an interface already created called Vehicle Interface. We'll see that in this interface, we have an engine start-stop, throttle, brake, steering, and a gear value. And it also has outputs for the vehicle speed, the engine RPM, and also the current gear of the transmission. One other thing we will want to add to this is the current chassis transform. So double click on the vehicle interface in order to edit it. And let's go look for the chassis in the folder physics, assembly. Then we have the main body part. And we can see that in its outputs, we have its world transform. And we can simply drag and drop this transform into the output section of the VHL. We can also click on it and press F2 to rename that value. And we can name it chassis transform. So let's save our mechanism and go back to Unity. So in our pickup truck game object, we'll add a new script by clicking on Add Component, New Script, and let's call this Truck Controls. Create an add, and let's double click on the script in order to edit it. In here, the first thing we need to do is to include the Vortex library, so using Vortex. Then in our class, let's instantiate our truck mechanism variable, so private truck mechanism. It needs to be of type Vortex mechanism. At the start of the simulation, we can assign our truck mechanism to that variable. So we can say truck mechanism will be equal to get component Vortex mechanism. And the first thing we can do to test if that works is to expose, for instance, the current speed of the vehicle. So let's instantiate the speed variable of type double. So public double speed. And then at each update, we'll gather that information from the Vortex VHL. So we can say speed is equal to truck mechanism dot get output real. Then we need to specify the name of our interface, which was vehicle space interface. And we also need to specify the name of the output. So the speed value, if we go back to Vortex and click on our vehicle interface, is called, well, it's called speed, so that's easy. Perfect, so we can save the script and we can already test if this will work in Unity. Let's start the simulation. And we need to start the Vortex simulation. As you can see, well, our truck is not moving, so we get a very, very small value. One other thing we can do to make it more convenient here is to automatically start the Vortex simulation when the Unity game starts. So we can do Vortex runtime dot start simulation, save, and with this, when we press play, it should automatically start the simulation. As you can see, I didn't have to click, and the simulation is already starting. The next thing we're going to do here is expose all of the inputs of the interface, so we can manually modify them from the game object. So here, let's instantiate all those values. So we have public bool engine start, public double, we have throttle, brake, and steering. And we also have the gear, which is an int value. There we go. Now the way we're going to be able to modify those values in the Vortex interface will be very similar than what we did to get the output. So we'll do truck mechanism dot set input boolean. Again, with the name of the interface, which is vehicle interface, and with the name of the input, which is engine running. So we can copy and paste this line for the throttle. In that case, it will be set input real. And the name will be throttle. And we can do the same thing for brake and steering. And also for the gear, which in that case will be set input int. I forgot to add a third argument to these functions, which is the actual value. So in our case, this will be our public variables. So let's start the simulation to test it out. So let's press play. Here we can see that the simulation starts automatically. And then we can maybe go back to the scene view. Engine start. We can gear it up. Increase the throttle. And we can maybe set the steering. Our truck is moving. Next thing we're going to do is to add a camera to our truck object. We can right click on it, click on camera. And of course we can position our camera to look at the truck. Now one thing you will notice if you start the simulation is that if you start the truck and make it moving, the camera is not following the truck. This is because the transform of the truck is not associated to our truck mechanism. So here let's stop the simulation and go back to our truck control strip. So what we'll do is we'll gather the chassis position from our VHL and we'll apply the position and rotation to the game object transform. So here we'll do var truck transform will be equal to truck mechanism dot get output matrix. So this function will get a matrix 4x4, which is the same format as the transform that we exposed in our VHL earlier. So again, the name of the VHL is vehicle interface. And then the name of the output is chassis transform. Next, we can write that our transform dot position will be equal to the truck transform dot position. And we do the same thing for the rotation. So let's save this and test it out again. If we press play, start our truck again, we will see that our camera is actually following the truck. And here, even if we change the position of our camera, it will still be following the truck because it's a child of our game object, and the transform of our game object is following the truck mechanism. Now, if we want to have a bit of fun, we can sculpt our terrain a little bit. Now, the last thing we're going to do is we're going to see how we can use the remote debugger in order to debug the Vortex simulation. So you can already start the simulation, and from the Vortex menu, you can launch Remote Debugger. This will open two windows, so a 3D viewer and a Remote Debugger panel. So in the simulator section, you will want to put your local address. So if you're, of course, simulating on the local computers, this will be 127.0.0.1. If you're running this on a network, you will have to put the static IP address of the computer running the Vortex simulation. Now, the port, if you remember earlier, we set that in our setup file. This was 55,000. And make sure that you do enable automatic content loading so that you will see the 3D assets on the 3D view. Then you have the dynamics display that you can activate or deactivate, but that can be done while it's simulating. So here, let's click on Connect. Let's deactivate the parts origin display as well as the contacts and maybe the center of masses, so we can see what's going on a bit faster. So if we go back to Unity, we can maybe drive the truck a little bit. So engine start, gear, maybe steer a little bit so it goes in circle. And if we go back to the 3D view of the remote debugger, we see we can have a good view of what's happening. You can even activate or deactivate the collision geometries, but of course you won't have a 3D view of the terrain if you do that. So that's it for this tutorial. I hope you enjoyed it, and see you again next time. Thanks.